Leaving cert higher level, 2016 paper 2 question 8 is a trig function and it deals with water in a port. The height of water in a port measured over time and the average height was found to be 1.6 meters. The height measured in meters, h of t, was modelled using the function h of t is equal to 1.6 plus 1.5 cos pi t over 6. T represents the number of hours since the last high tide, so that means that the high tide is my period. Pi t over 6 is measured in radians. Okay, find the period and range. Well, the period is 2 pi over c, where c is the coefficient of t always. So 2 pi divided by pi over 6 is equal to 2 pi, turn it upside down and multiply, times 6 over pi. The pi's cancel and we're left with 12, and we were told it was in hours. Now the range is the max and min value of my function. So what's the max cos? Cos max value is equal to 1 and the min is equal to minus 1. You know that from your unit circle. All these points for cos and sine. Sine max and min is 1 and 1 as well up here and down here. So this being the point 1, 0 and so on. So the max value here is going to be 1.6 plus 1.5 times 1, which is 3.1 meters. And the min value is 1.6 times 1.5 plus 1.5 times minus 1, or minus 1.5, which is equal to 0.1 meters. So we write our range like this, 0.1 to 3.1. Part B, find the max height of the water in the port. Well, we've already got that, and you couldn't really do part A without getting that, so someone in the exam commission must have had a bit of a brain freeze with part B. So the max height is 3.1 meters. If you want to show the work in this part, 1.6 plus 1.5 times 1 is 3.1 meters. So marks for the same question twice. Part C, find the rate at which, well, rate is rate of change, so we're looking at dy dx with y and x, h and t in this case, at which the height of the water is changing when t is equal to 2. Correct the 2 decimal places and explain your answer in the context of the question. Okay, if we look at it, I'll write my function out fully again. H of t is equal to 1.6 plus 1.5 the cos of pi t over 6, pi over 6 times t, or pi t over 6. So h prime t, cos goes to minus sine, and if we differentiate a number it just goes to 0, so we're just going to get minus, because cos goes to minus sine, minus 1.5 sine pi t over 6, and then what we have to do is we have to multiply by the differentiated angle. So if we differentiated 5t we'd get 5, 6t we get 6, pi over 6 times t we get pi over 6. So now pi stays as an angle inside there, but when it comes outside of here it turns into a decimal, 3.14 or 3.142. Now you can change your calculator to radians, or you can do it in degrees here. H prime t is equal to 2 is going to be equal to minus 1.5 by the sine of pi over 6 times 2, and then we're going to multiply by 3.142 divided by 6. So pi over 6 is 30 degrees, 2 30s is 60, so you can use degrees here. Minus 1.5 by the sine of 60 by 3.142 over 6. And if we type this into a calculator, we're going to get minus 0.680, so minus 0.68. So the water is going down, and it's going down at 0.68 meters. So water receding or something similar, going out at 0.68 meters per hour, 2 hours after last high tide, So what we're looking for here. Part D of this question, you're told on a particular day, high tide occurred at midnight, i.e. t is equal to 0, so we can fill that in here. Use the function to fill in the table below. So we can do t in hours first. 3 hours later, 6 hours, 9 hours, 12 hours, 15 hours, 18 hours, 21 hours, and 24 hours. And then there should be consistency with this, it's up and down. So the height when t is equal to 0, well, that's our unit circle. The cos of 0 is equal to 1. So at midnight, when t is 0, the height is going to be at a max of 3.1. Let's just have a look at our unit circle again. So here's my 0.10, my point over here, -1, 0. So this is 180 degrees over here. So when this is equal to 180, when is this equal to 180? When it's just pi, so t will be equal to 6. So that'll give me a minimum value of cos of -1. So that's going to be the lowest point, is going to be when t is equal to 6, so that's 0.1. At 90 degrees, we have the point 0, so cos is equal to 0 when this is 90 degrees. So if that's going to be pi over 2, so 3 pi over 6 when t is 3. We can see here 3 pi when t is 3. We're going to get 3 pi over 6, which is pi over 2, which will give that cos value 0, so it's going to be a 1.6 here. And that should start us now with our pattern. So if we come down to here at 270 degrees, well, t is equal to 9. Let's just check. We're going to get 9 pi over 6, which is going to be 3 pi over 2. That's my 270 value down here of 0 minus 1. So cos is equal to 0 there again. So that will be 1.6. After 12 hours, 12, t is equal to 12. Let's just fill them in here. T is equal to 12. We're going to get 12 pi over 6, which is 2 pi. So we're actually back around full circle to here. So it's going to be equal to max value of 1. So that's my 3.1. And then it just mirrors off from there. This has to be 1.6 because we are going up 3 pi over 6. We're going to pi over 2 each time. So we're rotating around the unit circle 90 degrees each time. So this would have to be 0.1. 1.6 and 3.1. Let's double check just this one here when t is 21, just to double check that we're right with our pattern. T is equal to 21. We're going to get pi t over 6, so we're going to get 21 pi over 6, and both of those divide by 3, so we're going to get 7 pi over 2, which is 7/90, which is 630, which is 90 degrees before 720, which is this point here where we said cos was equal to 0. So it would have a value of just 1.6. So that's the table in part D1. D part 2, you're asked to graph it. Now, you were given really scale graph paper in the exam, so easy enough. If you weren't, just graph the function first and then put your values in. But let's put our minimum values and our maximum values in. So our max are at midnight, 12 noon, and back around at midnight again. So midnight, 12 noon, and back around at midnight again. And our minimum values must be the midpoints of these. So 6 a.m. and 6 p.m. And that was 0.1, so just put that on 0.1 here and here. And that's enough to draw it down. Just curve it down and up and down and up. So you'd be a little bit more accurate than me drawing without graph paper here. But that's an approximation, let's say, of a sine graph. You'd always do it in pencil in the exam and go a little bit slower, but I don't have that option here. D part 2, you're asked to find the difference in, using the sketch, to find the difference in height between low tide and high tide. Well, mine just came a bit at 3, it should have been at 3.1 as we know from above, 3.1 to 0.1. So that's back nearly to part 1 again, 3.1 minus 0.1 to difference is 3 meters. So part F, fully loaded barge enters the port. D part 2 was actually part E, that's why this is part F. It requires a minimum water level of 2 meters when fully loaded and 1.5 meters when unloaded. Use your graph to estimate the max amount of time the barge can spend in the port without resting on the seabed. So enters at 2, has to leave before it gets below 1.5. Okay, well here's 2 and here's 1.5. So it needs to enter on the way up. If it enters at 2 here, it's just going down. So it needs to enter here. And it can stay in port all the way while the tide is rising until the tide gets back down to here. So this range of values here. So if you've done a really accurate graph like I haven't, this will be an easy answer to get. Let's just see where my drop downs give me. So I drop down. Looks like it's, what would that be, about 10 possibly on my graph, and about 4. So my graph has between 10 and 4, which is 6 hours. The exact answer in this case was 15, not 10. 10? Yeah, it's 10, yeah. The exact answer was 9:30, actually not 10, 9:30. And leaving at 15:15. So I got 6 hours. The exact answer was 5 hours 45 minutes. You can see why an accurate graph would give you a better answer. However, in this case, the Examinations Commission accepted the answer from your graph. So once you gave an answer from your graph, you got full marks. So I would get 5 full marks for my per attempt. Although it wasn't too poor, we were only a couple of minutes off. So that's the end of question 8.